All right, this is AP, AB, and BC Calculus. We're doing Unit 8, Section 6, which is finding the area between curves that intersect at more than 2 points. So let's go ahead and get right to it. So when curves intersect at multiple points, they will often, and sometimes, but really it's often, switch which curve is physically on top. If this happens in a calculator section, so if this is a calculator section, right, then there's a shortcut. If there's a calculator section, then I don't care what the three locations are. So here we'll call this one A, we'll say that this one intersects at 0 and this one's B. If it's a calculator section, I'm able, so on a calculator section, I could just integrate the entire thing from A to B, right, from A to B, and I could do the absolute value of whichever curve I want minus whichever other curve I want. It really doesn't matter, because it doesn't matter which one's on top. So I could either do this or I could do F minus G. It doesn't matter which order, like it doesn't matter if these are switched, okay? If it's a non-calculator section, then I have to pay attention to which curve is on top and I have to integrate two different pieces. If it's non-calculator, I'm gonna have to do this section with G on top and F on the bottom. So if it's non-calculator, right, I would have to integrate from A to 0 of G of X minus F of X. And then I would have to separately integrate from 0 to B of the reverse, where it's F on top of G. So I'd have to integrate from 0 to B of F of X minus G of X, because they switch which one's on top. So you can see how this is much easier on a calculator section, and you're absolutely totally valid in writing this on a calculator section and then just getting the answer. But on a non-calculator section, you're gonna have to pay attention to where the curves intersect. So we're gonna walk through a bunch of these problems, some calculator, some non. So non-calculator first, and we will check this on our calculator, but we're going to treat it as a non-calculator problem. So we're going to find the area between the two curves. The first thing I need to do is find the bounds. So in order to find the bounds, I'm going to find where these two things intersect. So I need to find where x cubed minus 3x equals x. Well, that's when x cubed minus 4x is 0. If I factor out an x, I get a difference of squares. So I can see that the 3 points of intersection, sorry, I will keep factoring before I set them equal to 0. The 3 points of intersection are at x equals 0, x equals -2, and x equals 2. I don't really have to do a detailed graph of this. All I need to know is that a cubic that's positive looks like this, and a line with a positive slope looks like this. That's probably enough for me to get a really basic version of this graph. It looks like this, which means that F is on the top in the first interval and G is on the bottom, and then in the next interval it's G on top of F. It's generally enough to just have a basic knowledge of these curves, because if the question is coming up on a non-calculator section, it's probably a fairly basic curve. Knowing what a positive x cubed looks like is probably enough. So once I know that, and I know the points of intersection, I know this is a -2, I know this is 0, and I know this is at 2, I don't really have to have a nice fancy diagram. I just need to say that the area of inside this curve is going to be the integral from -2 to 0 of f of x, which would be x cubed minus 3x, minus g with respect to x, plus the integral from 0 to 2 of g, which is the x, minus the quantity x cubed minus 3x with respect to x. And then I do the integration by hand because it's a non-calculator section. So if I clean this up, this thing on the inside is an x cubed minus 4x. This thing is the reverse. This thing is a 4x minus x cubed, or negative x cubed plus 4x, doesn't matter. So when I integrate, I'm going to get that this is an x to the 4th over 4 minus a 2x squared, evaluated from -2 to 0, plus this one's going to be the reverse. It's going to be the 2x squared minus the x to the 4th over 4, again from 0 to 2, right? And we're gonna go ahead and do it by hand and then check on a calculator, right? So you'll most often see, so you're gonna see this type of problem on a calculator section a lot. It probably won't be this straightforward with polynomials. So when I plug in the first one, right, I'm gonna get 0 minus 0 minus, when I plug in the bottom bounds, I'm gonna get a positive 16 over 4 minus a 2 times 4, so minus an 8, right? And we'll deal with that in a sec. When I plug into the second one, I'm going to end up getting that this is a 2 times a 4, so that's an 8, minus a 16/4, right? And then minus a bunch of zeros, right? Because when I plug in 0 to those x's, they're gone. So I end up getting that this is a negative of a -4, because that's 4 minus 8, plus this is an 8 minus 4, so that's a 4, so I get 4 plus 4, which is 8. So I should check this answer in a calculator, right? The nice thing about checking in a calculator is I can do absolute values, so I don't care what the bounds are, right? So all I need to do is integrate from here to here, right, with an absolute value. So it's up to you if you want to put them in as your y1 and your y2, you certainly can. It may or may not be worth it in this case, especially since one of them is just x. Usually the y1 and y2 trick is most useful when your graph is really, really ugly, right? And neither of these is awful. So if I quit out of this, right, I'm going to do math 9, right? I want to go to math over to number and pick absolute value. And then really it doesn't matter which one you call y1 and y2. It doesn't matter which order you subtract them in because you put them in an absolute value, comma, with respect to x, right, from -2 to 2. And again, I can skip right over 0, and there's my 8. The reason I can skip over 0 is because the absolute value makes it not matter which function's on top when. All right, so moving on. All right, so P1, you're going to try the same thing. Again, I'm going to suggest you find the bounds first, right? That's the only way to proceed. So let's go ahead and find those bounds and then go from there. So first thing you're going to do is find the bounds. You find the bounds by setting the two functions equal. So x cubed plus 5x squared plus 5x equals -x. X cubed plus 5x squared plus 6x equals 0. When I take out a GCF of x, I'm left with a quadratic trinomial that hopefully we're pretty good at factoring at this point. So I have an x times an x plus 2 times an x plus 3. Seems to me that my three zeros are 0, -2, and -3. So again, I'm going to argue that you don't need to know much beyond the fact that this is a positive cubic and a negative x. The cubic looks like this, right? And a negative slope looks like this. So what we're going to have here is we're going to have the curve on top of the line and then the line on top of the curve. So if you're doing this by hand, and again, you know the places where they intersect. This is at -3 because that's the first one numerically. This is at -2 and this is at 0. So if you're doing this by hand, your area is going to be the integral from -3 to -2 of f, which is x cubed plus 5x squared plus 5x minus a -x, right? So actually, we'll write it as minus a negative just to make the point, and then we'll clean it up. So minus a -x with respect to x, plus the integral from -2 to 0 of the -x minus that whole crazy thing, right, with respect to x. So if you clean them up, they're actually both going to look like this. One of them is just going to be negative and one of them is going to be positive, right? So if you clean them up, and I'm just going to come down here, I get that this first one, the integral from -3 to -2, is an x cubed plus a 5x squared plus a 6x. And then the other one is literally going to be exactly the same thing, but with all of the opposite signs, because there's a negative in front of all of these things and this negative in front of the x. So it's going to be -x cubed minus 5x squared minus 6x with respect to x. So it's the same basic problem, right? So what we're going to get is we're going to get that this is an x to the 4th over 4, right? Plus a 5/3 x cubed plus a 3x squared from -3 to -2. And this one's no fun because your bounds aren't always zeros, so that's less fun. This is a -x to the 4th over 4, but you notice it's the same antiderivative just with a minus in front. A -5/3 x cubed and a -3x squared. And again, we're plugging in -2 to, this one's at least a 0, so that's slightly nicer. All right, so we're going to get a bunch of fractions. I'm going to say you should hold off on getting common denominators because I think you're going to find some of them sum pretty nicely. So when I plug in top minus bottom, I'm going to get 16 over 4. This is going to be a 5/3 times a -8, which we'll deal with in a sec. And this is going to be a 3 times 4, so that's a 12, right? That's my top bound. Minus, when I plug in the bottom bound, I'm going to get an 81 over 4 plus a 5/3 times a -27, which we'll deal with in a sec, right? Plus 27, right? Because it's 3 times 9. When I plug in over here, my top bound is a bunch of zeros, so that's nice. Yay, zeros. The bottom bound is going to be a -16/4, right? Because there's a negative in front, right? This will end up being, this is a -5/3 times a -8, which is going to get cleaned up pretty nice because some of those negatives will go away. And then this is going to end up being minus a 12. Sorry, I wrote plus and I meant minus. This is going to end up being minus a 12. Okay, so let's clean some stuff up and see how it goes. So I'm going to go ahead and make the 16. So this 16/4 is a 4, right? And I have a minus 40/3, and there's not much I can do with it. I'm going to go ahead and actually put these guys together. So let's not make that a 4. Let's make that a 16, right? Because it's 4 and 12. So let's make that a 16. Minus 40/3, right? This is going to be minus an 81/4, which I can't do much with right now. The 27 and the 3 can cancel to give me a 9, so that's a minus 45 plus a 27. And actually, let's not make that a 16 yet. Let's give ourselves a little time to combine this because it's a lot of stuff. It's 4 minus a 40/3 plus a 12, right? So that's what I got from the first one. This is the second section. The 0 doesn't do anything. This negative is going to end up making this a positive 4, right? This was a positive 40/3, so now it's a negative 40/3, right? And this was a negative 12, so now it's plus 12. Okay, so now I'm going to suggest that we put together any numbers that are already matching, right? So I'm going to go ahead and put together the whole numbers, because why not, right? So let's do them first. So it seems to me that everybody's positive except the 45. So I have a 16 and another 16, so that's a 32, right? And I have a 27, so that should be a 59. So I seem to get 59 minus 45, which would be, I believe, a 14. I also have some things that are thirds, right? I have a negative 40/3 and another negative 40/3. Unfortunately, they're not opposite signs, but that's okay. I get a negative 80/3. And then I have this poor little negative 81/4, and that's the best I can do. So it looks to me like my common denominator is sadly 12. It's no fun, but it is what it is. So I go ahead and do 12 times 14. I don't know off the top of my head, but I believe 12 times 12. Oh, that's easy way to do this. All right, so this is 144 plus a 24, right? So that's a 168? Yeah. So I get, this is 168 twelfths. And again, this is not super fun. It's a little bit tedious. This needs to be multiplied by 4 over 4. So that's a 320 over 12, right? And this needs to be multiplied. Why am I getting such a big negative answer? That shouldn't be negative. Hold on. So the reason I'm pausing for a sec is because that shouldn't be negative, right? And if I'm not mistaken, these are both pretty big negative numbers. So if we do 3 times 81, we get 243. So the reason I'm pausing is because these two numbers are both negative and they're bigger than the 168, which is not right, so something's up. So let's go back and check our signs real quick. Because the 45 is positive and the 27 is negative. My bad. So that changes things slightly, so it's not a 14. It means that the green stuff adds up to, see, this is why it gets tedious sometimes when you're doing these things. So that's a 32, and that's also a 32. 32 and 32, so sorry, 32 minus 27 would be a 5, and then I add a 45, so I get a 50, and that makes a big difference, because now 50 times 12 is a 600, and boom, suddenly we're in the positive, and that's it. So it's simple that just accidentally when I distributed this negative, I missed a sign and I didn't distribute it, and that caused a lot of problems. So I could go back and delete that from the video. I'm not going to, because I want you to get how that is incredibly frustrating, but it's a thing that happens, right? So now I have a 600, 320, and 243. If you really didn't have a calculator, please don't be ashamed to literally sit there and add, right? So minus 563 all over 12. Should give me a 37 over 12, right? That's what I should be getting. So I think, unless I did something crazy wrong, but we'll find out in a sec, huh? I don't think I missed any of the other negatives. I think they're right. All right, so I get 37 over 12, which is a little bit over 3. So let's see what happens if we check it in the calculator, because we should absolutely check this in the calculator. So I'm going to go ahead and just type over and change my values from last time, because I already did all that work checking things in the calculator, so why would I not do that, right? And this was a negative x. Cool. All right, so then I'm going to quit out of this, and I'm going to second enter, and now the only difference here is my bounds are now a -3 to a 0, but other than that, I can keep everything else the same. And if we math frac, it may not let me. because it's an approximation and it might not be close enough. So it won't let me math frac, but we can do 37 over 12 and check that it's close. And sure enough, that's the right answer. So that was tedious and frustrating. But I also want you to notice that I got a big red flag when my answer was coming out negative, because I know my area shouldn't be negative if I'm doing everything right. It's important to not panic when something like that happens, right? Most of the time, if your answer goes slightly awry, or if you realize you get a negative and you should have a positive and you start to panic, take a deep breath and realize it's probably something super simple like accidentally misdistributing a negative, okay? It happens to all of us, so just be aware it's a thing. Okay, so when we see that this is a calculator section, we should be super duper stoked and happy. Because once it's a calculator section, I know that all I have to do is set up what the integrand should look like with the correct bounds, and then type, boom, there's an answer, and none of like this crazy mind-numbing pain. Yikes, right? None of that. So let's go ahead to our y equals, right? And we're gonna go ahead and put in x squared. I'm gonna make the plug yet again that I keep making, which is that you best be in radian mode. It doesn't matter for this particular problem, but it's gonna matter at some point, and one of you's not gonna be in radian mode, and then you're gonna be really sad. So I get a negative 0.4x plus 3, right? So we're going to go ahead and graph these. So zoom 6 as your standard. If you can't see it, that's fine. So these are the intervals we're talking about, right? So we're talking about this interval and this interval. So honestly, since I'm using a calculator, the only 2 points of intersection I need are this first one and this last one, because I don't care that they flip-flop. I'm doing it on a calculator. So I'm going to second calc intersect. And I want the first spot they intersect. I'm going to go all the way to the left, which is tedious and annoying, but it is what it is. All right, so enter. There we go. Okay, so I'm going to go ahead and say that the first point of intersection, so I'm going to say that A is approximately negative 7.3788128 ... right? So that's the x value I'm going to use is A. Right, now I quit out of that, and I need to go ahead and store that, because otherwise I can't use it. So I'm going to store that as alpha A. Cool. All right, and then I'm going to go back to my graph, and I'm going to second calc intersect. And again, because I'm using a calculator, I don't need the two sections. Oh, interesting shortcut. See how I'm on the curve, and that's longer? If you hit down, it'll put you on the line, and the line moves faster, because the shortest distance between two lines in a two-dimensional plane is, or between 2 points in a two-dimensional plane is a straight line. So I say that my B, right, is approximately this 1.2967676, ... right? And I'm going to go ahead and quit out and store that too. So I'm going to hit X, right? I'm going to store that as alpha B. Cool. Now that I've stored them, that's the first part of my job, right? The second part of my job is to literally just say what the area is, which is that the area is the integral from A to B of the absolute value of, it doesn't matter which order you subtract them in, because there's an absolute value, and then type and get the answer. So I'm going to go ahead and hit math 9, right? I'm going to go to math over to number and pick abs. And then I don't care if I do y1 minus y2 or y2 minus y1, because I'm doing it in an absolute value and it doesn't matter. Close the absolute value, comma, with respect to x, from alpha A, which I have stored, to alpha B, which I have stored, hit enter, boom, there's your answer, right? That's what the AP needs from you. They need you to communicate that you understand what's happening, right? This is your communication that you understand what's required to find this value, right? You need to find the bounds. You either need to write the bounds, like label them off to the side as A and B, and say what they are and use letters that are not used in the problem, or you need to write the entirety of these digits down here. You cannot round or truncate to the thousands place unless it's the final answer. Please don't round before your final answer. Please don't listen to anyone that ever tells you to round before your final answer. That's how bridges fall down. That's how buildings fall down. That is not accuracy. Be accurate. Okay. Try P2 on your own. Again, if you just did E1 or E2 rather with me, you already can basically plagiarize your own work in a calculator by hitting second enter. So I'm going to go ahead and put, I'm going to change my y1 and my y2, right? So my y1 is going to be the natural log of 0.3x squared plus 1, right? As a side note, I'm not actually encouraging actual plagiarism, right? That's a joke when I say plagiarize yourself. But you should use your own existing work in the calculator if you can, right? Second enter is dope for a reason. All right, so I'm going to go ahead and graph. And again, I need those points of intersection, but because I'm going to use the absolute value trick, I only need the first and last one. I don't care about the point where they flip-flop, right? So I'm going to do second calc intersect, which is 5. I'm going to go to the first one, enter, and then I'm going to go ahead and store that, right? So my A, right, my A is approximately negative 2.045188, ... right? And I'm going to quit out, right? And I'm gonna store it because remember we saw in a previous video or on this video maybe that I didn't store one once and then it was the worst because I had to go back in second calc intersect again. So second calc intersect again. For the other one, again, I don't care about this one in the middle. I only care about the one on the end, right? I only care to find that one. I find B to be approximately 1.9351363, dot, 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 dot. I'm going to quit out because I want to use that. And so I have X, right? And I'm going to store as alpha B, right? And then you can either, so it might seem like a pain to go all the way back up after all that storing, but you can second enter a bunch of times. So you could second enter all the way back up if you think this is the faster option till you get to the one that you just had. And then you literally just hit enter. You don't have to retype it because it's the same thing with two different functions. And there's my answer. Now remember, I have to find the bounds. I have to communicate what the area is, right? The area is going to be the integral from a to b of the absolute value of f of x minus g of x. If the AP does not call these function names, like if they just say y and y, you have to write the entire function rule. You have to say what it is. And then my job is to put the approximately and put the value rounded or truncated to 3 places. You don't put both, right? You just put one. It's my job as the teacher to know that they're the same thing. All right, so let's do a non-calculator, right? Yay, and I meant that sarcastically. So a non-calculator in terms of y, this is the same example as the first two we did. Really, it's just in terms of y instead. So I have to find the bounds first, right? Which is going to mean that I set y equal to y cubed plus 2y squared minus 2y. 0 equals y cubed plus 2y squared minus 3y. And now I factor, and I'm going to get that this is another nice, happy quadratic trinomial. What makes this awful is not that it's difficult to factor. What makes this awful is that it's going to be tedious and frustrating to integrate, right? So again, you can kind of cheat with your knowledge of what graphs look like. So if you know what a positive y cubed looks like, you can figure out which one of these functions is on top. As a side note, if you really don't care which function's on top or which function's on the left or right, and you could not possibly care less, there's also another cheat. You can just integrate over each interval, you can integrate whichever one you want minus the other one. And then if it turns out you're wrong, you'll know it because you'll get a negative area and you could just go back and put a minus in front of your integral in every single step and then make the answer positive. That's a legit thing you could do. It's a thing I've done in a panic before when I realized after the fact that I accidentally integrated the wrong order. So you could totally be like, cool, I messed up. I see that I got a negative for that particular integral. It must have been in the opposite order. I will go up and put a minus in front of the whole integral in every single step and it will change the sign. And that's a really great shortcut. I'm not going to advocate that as like your plan all the time, but it's a really good shortcut if you realize that you've done something wrong. So one easy way to figure out which function is on the right or the left, and I know this sounds kind of silly, but you have the 3 values, right? Just pick a value between them. So the 3 values that you care about are when y is -3, when y is 0, and when y is 1, right? You could just say, hey, I'm going to pick an f value at, let's do -1 and let's do, I don't know, 0.5, right? And see which one is physically larger, right? If I plug in, for f of y, if I plug in -1, I get a -1. If I plug in a 0.5, and this is where it's not super fun because unfortunately it's not fun to plug in a 0.5, but if I plug in a 0.5, I'm going to get a 1/8, right? Plus a 2 times a 4th, which would be a 0.5, minus a 1. That definitely comes out to be bigger. So this is sorry, I put that in the wrong spot. My bad. This should go here. My bad. Tired brain. Okay, so that's my g, right? This is definitely a smaller negative number, so that's the bigger one, right? Again, not as easy to see. Come on, brain. My brain is tragic, people. I put that in the wrong place twice. Okay, sorry. If I plug in the -1 for g, right, I'm going to get -1 plus 2 plus 2. That number is definitely bigger than the -1. So this is the function that's to the right in that window. Right? If I plug in 0.5, I get a 0.5. That one's easy. But if I plug in 0.5 into the other one, that's when I get the thing I did a second ago that I totally wrote in the wrong place 2 separate times because my brain is tired. Plus a 0.5 minus a 1. This is a positive number. This is a negative number, meaning this is definitely to the right. So basically, what happens is when I integrate from -3 to 0, the right function is g. And when I integrate from 0 to 1, the right function is f. And again, that's like a pain, and it's not fun to figure it out. And if you don't know what the graphs look like, that can be harder. If you realized after you integrated each of these pieces, if you realized that this one accidentally came out negative, you'd be like, oops, I did a thing wrong, and you'd put a minus in front of every step and then make the number positive. So notice that both of them are actually this function. It's just one of them is this function, one of them is the function with the signs in the opposite order, right? So this one is actually y cubed plus 2y squared minus 3y, right? This one's exactly the same thing, but with the signs all in the opposite order. So negative y cubed minus 2, like if you did f minus y, that's what you get, or sorry, f minus 2, that's what you get. So so it's the same integrands too, right? Like when you do the antiderivative, it's going to be the same one, it's just the signs are all different. So this is going to be a 2/3 y cubed minus a 3/2. Oh, this one's extra fun because there's so many fractions. So again, like totally not going to see very many of these on a non-calculator. I apologize in advance if this feels tedious. You should check them on a calculator, and hopefully most of them you'll see are designed to not be super duper tedious if they're non-calculator. They can be a little tedious. This second one's not bad because it's a 0 and a 1. The first one's just icky because of the -3. So when I plug in my values, right, I'm going to get that this is an 81/4 plus a 2/3 times a -27, which is, we'll leave as a 2/3 times a -27 for now, even though we could clean it up, minus, oh, I didn't plug in the 0. People, my brain. Sorry, it's been a long day of math videos. The 0 is the top power. 0 minus, and then this one's going to be an 81/4 plus a 2/3 times the -27 minus a 3/2 times a +9, right? That's the whole first one. So this first one is a negative times, this is 81/4 plus, I can cancel the 27 and the 3 to get a -9, so that's minus an 18, right? And then this is a minus 27/2. So this thing's definitely going to come out positive because these numbers are bigger together than this number. So it's definitely going to come out positive. So if you want to clean it up, you certainly could, right? Like you could make this is an 81/4, which means if I multiply this by 4, my brain just died. It's a 72. 72 over 4, and then if this is a 54 over 4, right? Multiplied by 2, right? So I end up getting 81 minus 72 is a 9, positive 9, right? And so then the 54 is negative and the 9 is positive, so that should be a 45. So I should get a negative of a -45, which is a positive 45/4. So this definitely came out positive, which means I subtracted in the right order. If I do the other half, right? The other half's actually pretty easy, right? This is going to be a -1/4 minus a 2/3 plus a 3/2 minus a bunch of 0, right? Because all those would be 0 when I plug in. So I'm going to end up getting that this is a -1/4. I guess I should make my common denominator 12 for this one, right? Because I see the 3's and I see the 2's and the 4. So I'm going to go ahead and make this 12. So this is -3/12, right? Minus 8/12, because the common denominator I'd multiply by 4, plus 18/12. Checks out. So this thing ends up being, so these together would be a 10/12. So this ends up being a 7/12, which is also positive, right? So that's a good sign. So this is also positive, which means I subtracted in the right order. So my final answer is going to be the 45/4 plus the 7/12. I need a common denominator. So that would mean a 12, right? So I multiply by 3 and get a $1.35 over 12 plus 7 over 12. So after all that work, I get a 142 over 12, which I could cancel a 2 out of if I want, although I'm not sure that I want. So it'd be this, and that's where I land. So after all that, right, I landed a 71 over 6, and I'm not entirely sure I'm right, and that's why by hand problems are really, really frustrating sometimes. So let's go ahead and check it. I'm going to go ahead and go to my y equals. I'm going to put in, remember that you're using x in place of the y's. So it's an x instead of a y, and this is an x to the third plus a 2 y squared, which is an x squared in this situation, minus a 2y, which is an x in this situation, right? Again, if I'm checking on the calculator, right, so I can quit out of this. If I'm checking on the calculator, I don't care about anything. I don't care which one's y1 and y2, and all I care about is the first and last bound. So I'm going to do -3 to 1. We're going to see what happens, right? And then we're going to math frac it. hey, 71 over 6. And so like we feel slightly redeemed after a really long, frustrating non-calculator problem. I'm not doing these because you're going to see a ton of these problems by hand. I'm doing them because if you do see a problem by hand, I want you to be prepared for what it's going to look like. So I promise only one more by hand. We're going to do this one by hand, and then we'll have 2 more calculator ones, but calculator ones that are in terms of y, just to make sure you understand how to plug in x's instead of y's in your calculator. So first thing I have to do here is I have to find the bounds, right? So that's when negative 2y equals y cubed minus 4y squared plus y. So that's when 0 equals y cubed minus 4y squared plus 3y, right? When I factor this, I get a y squared minus 4y plus 3, which is definitely going to factor into a y minus 1, y minus 3. So my 3 bounds are going to be 0, 1, and 3. So y equals 0, 1, and 3, right? Again, if you want, you could just pick easy numbers between those and see which value is physically larger, right? Like you could see which one's farther to the right. So if you want, right, so here's 0, here's 1, and here's 3, right? So you could pick, let's say x is 0.5 again, which was no fun, but it's all right, and then x is 2, or sorry, y is 0.5, and then y is 2, and see what happens and see which number is bigger. If you plug in 0.5, let's just get this one out of the way. F of 0.5 would be a negative 1, right? G of 0.5 is the one that's going to be awful, right? So that's going to be a 0.125 minus a 4 times a fourth, so that'd be minus 1 plus a 0.5, right? So that's definitely more positive than the negative 1, so that's the right of the 2 functions. If I plug in 2, I get that f of 2 is a negative 4. If I plug in 2 here, I get that g of 2 is an 8 minus a 16 plus a 2, right, which should be a negative 6. So this is definitely the right of the 2 functions. So what would happen is that my area, right, my area is going to be the integral from 0 to 1 of g minus f, so g of y minus f of y with respect to y, plus the integral from 1 to 3 of the other direction, right? Now, again, if you were like, hey, Hogan, you know what, I'm just not going to check, I'm just going to always do f minus g, then you just have to pay attention at the end, and if you get a negative on one of these two, you have to go back and put that negative in on every single one. That's a choice. I mean, it's not a choice that I personally would make, but it's a choice some people would make, so that's the thing. So notice that both of these are actually going to be this function. It's just one of them is going to be that function as a positive, and one of them is going to be that function with exactly the opposite signs. So g minus f is going to be this function. So the integral from 0 to 1 is going to be of y cubed minus 4y squared plus 3y. And then the integral from 1 to 3 is going to be the exact opposite. So negative y cubed plus 4y squared minus 3y with respect to y. They're going to have the same antiderivative, just with different signs, right? So I'm going to get that this is y to the 4th over 4 minus 4/3 y cubed plus 3/2 y squared from 0 to 1. That one won't be bad because the bounds are 0 and 1. Plus this one's going to be a y to the 4th, sorry, negative y to the 4th over 4 plus a 4/3 y cubed minus a 3/2 y squared. And this one's really only awful, I would say, because the 3 makes it worse. 1s aren't awful, but the 3 is a little bit worse. So when I plug in this one, I'm going to get 1/4 minus 4/3 plus 3/2, right, minus a bunch of 0. And honestly, you might want to leave this as is long as you've verified it's positive, right? As long as you feel comfortable that you did subtract in the right order, because some of those values are going to cancel probably when I do the other half. So here, when we plug in 3, we're going to get a negative 81/4 plus, this is a 4/3 times a 27, so at least I can get rid of the 3 on the bottom. That'll be nice. Minus a 3/2 times a 9, right? And then when I plug in the other ones, that'll be minus. I'm going to get negative 1/4 plus 4/3 minus 3/2, right? So when I distribute some stuff, I can probably cancel some things, or at least combine some things that already have the same denominator. So I have a negative 1/4 minus 4/3 plus a 3/2, right? Minus 81/4, which we'll deal with in a sec. This I can cancel and make it 9, so that's a plus 36, so that's kind of nice. This is going to be a minus 27/2, right? And then here I'm going to get a plus 1/4 minus 4/3 and a plus 3/2. So none of these things actually cancel because they end up being the exact same sign. But I could combine things like my fourths. So I'm going to go ahead and put my fourths together first, right? So I have 1/4 and another 1/4. That would be 2/4, right? 2/4 minus 81/4 should be a negative 79/4, right? I also have negative 4/3 and another negative 4/3. So we have a negative 8/3, good times, right? And then I have a 3/2, a negative 27/2, and another 3/2. So that's 6/2 minus 27/2, which seems to be a negative 21/2. And then I have this lovely plus 36 that's just kind of chilling, right? Unfortunately, the common denominator between these things is a 12, and so that's good times. So I'm going to I multiply this by 3. If it were an 80 times 3, it would be a negative 240. So it's 3 shy of being a negative 240. So it should be a negative 237. That seems to check out. Negative 237 over 12 minus, if I multiply this by 4, I get negative 32 over 12, right? And if I multiply this by 6, I get a $1.26 over 12. And then 36 times 12 would be the same as 12. So 12 times 12 times 3, right? So it'd be a $1.44 times 3. So 300 and a $1.20 and a 12, right? So 300 and a $1.20 is a 420 and then a 12, so 432, right? So I think this should be 432 over 12, right? If I put them together, it's not a bad time. Like, this is a bad time to be ashamed that you're like, I'm going to add these things together in a column. Like, these are all of the negative ones, right? They all go together. So this is a good time to just embrace it and lean in. So I get a 5, carry the 1, right? This is a 9, and then this is a 3, right? So it seems to me that I get that this is a negative 395 plus a 432. Again, not the time to be ashamed to do long math on the paper if you don't have a calculator, because, you know, why not? I'm going to borrow from here and get a 7. I'm going to borrow from here and get a 3. So I think I get 37 over 12, which I feel like we got on another one too. Just coincidence, but I feel like we got this on another one. So if we check it, that's kind of reassuring that we got the same answer. So if we check this, right, I'm going to go ahead and go to my y equals, right? I'm going to put in a negative 2x, right? And here I already have the x cubed, because remember that's my y cubed, right? So we already have the x cubed. This is a minus 4y squared, but it's an x squared. And then this is a plus just the x, right? That checks out, right? And then I can quit out. And then honestly, I can just second enter. We already have the absolute value we want. The only difference is I need to say that this is from 0, because that was the first bound, to 3. And then we'll see what happens. And hey, I'm pretty sure that that's our 37 over 12. Remember, we had this issue before where it's a rounded thing. Hey, look, there it is. All right, whew, okay, 2 more calculator problems, then we can stop torturing ourselves with this section. So if it's a calculator problem, remember your jobs on a calculator problem, you need some bounds, right? You need to find the bounds, you need to set up the integral, you need to type, and just give the answer, right? That's your job on this. So I'm going to go ahead and go to my y equals, and I'm going to put in x cubed minus x plus 1. Remember, I know that they're y's, but I have to type them as x's. Those are my choices. So 3.2 x, and then delete a bunch of stuff, right? I'm going to go ahead and assume that it's zoom 6. Sometimes you do have to adjust your window. So these are the 2 bounds I need, right? So I'm going to second calc intersect. Remember, you travel faster on the line than on the curve. So if you want, you can scroll to use up or down to switch curves. So my first one that I'm going to call A is going to be negative 2.159418, dot, right? So I'm going to call that A. I'm going to quit out. That's an X value, and I'm going to store it as alpha A, right? I'm going to go back to my graph. I'm going to second calc intersect again. And again, see how the curve is slower. If you go to the line, you'll move faster. So go on the line because that's a shorter distance. All right, and I get that my B is approximately a 1.917918, right? And I'm going to quit out, right? Second quit. I'm going to hit X, and then I'm going to store that as alpha B, right? So once I've done that, my integral, right? So then the area, so that's the first part of my job. The second part of my job is that the area that we want is the integral from A to B of f of y minus g of y in an absolute value, because we don't care which one's on top, with respect to y. And then the last part of my job is type, boom, there's an answer, right? Those are the parts of my job that I need to do. And if you know that, I think it makes the problems a lot more accessible. So again, we've actually done this. We can go back up a couple times if we want. If you don't want to retype everything, it depends on how many times you feel like hitting second enter. But we've done a bunch of these problems. There we go. So I'm just going to change this to alpha A and alpha B. And again, I could have gone back and typed everything from scratch, but why? So 179 or 180, depending on if you round or truncate. Again, you don't put both. That's my job to see which answer is right. Okay, so this one looks pretty disgusting, but it doesn't matter because it's the same job, right? Your first job is to find the bounds. Your second job is to write what that integral is. And your last job is to write what the answer is. Those are the entire jobs in this problem. So I go to my y equals. I'm going to put in y minus 3, but remember it's not y, it's x, right? Quantity squared, plus 2y, but that's x, minus 6, minus sine of x minus 3. And just a reminder, you have to be in radian mode, right? And here I have 2 minus y, but again I'm using x to the third, plus a y squared, but again it's an x, minus a 2y, yet again we're using an x. So double and triple check that you put everything in right, and then once you know you have, you can quit out, and you can hit second enter, right? Oh, sorry, didn't mean to hit second enter yet. Still need to find my intersections. Graphic. There are your intersections. So I see that it's here and here and here, but I only care about the first and the last one. So second calc intersect. That was close enough for the first one. Okay, so my first bound is going to be A is approximately, I think that was 0.661 before the 8. Yeah, 87504, right? Dot, dot, dot. And then I'm going to find B, right? So I'm going to second calc intersect. Enter, enter, enter. Close enough. Okay, and I get, oh, you know what? I did the thing. You're probably all like thinking this at home if you were paying attention, like, oh, Hogan, you forgot to do the thing where you store the value. I did. So I'm going to have to pay for that by doing it again. So I go ahead and store B because I have B right now. So store alpha B, right? And I have to go back and second calc intersect again because I accidentally forgot to store it, which is a good lesson. It has happened twice in videos now. It does happen when it happens on a test. You get frustrated because you wasted a little bit of time. But it's good to see that those things happen to people even that do a lot of math in their spare time. So for the integral, I need to write the integral not in math notation or not in calculator notation. It has to be mathy calculus notation, right? I want the absolute value of one of the functions minus the other function. It doesn't matter what order you pick because that absolute value takes care of that. And then I'm going to go ahead and put approximately, and then I need the answer. So to get that, I can either do second enter a bunch to go up to where I already had it, right? Or I can type it from scratch. Let's type it from scratch just in case anybody needs a reminder of how to do it. So we're going to do math 9, and then I need math, oh, my bad, math and abs, which is under number, right? I want to go to vars over to y vars and pick y1 minus vars over to y vars, pick y2, right? Close the absolute value, comma, with respect to x, which here is actually y, from alpha A to alpha B. And there's my answer. So I get a 3.174, and that's it. There's no rounding or truncating to a different answer. So that, I believe, is the end of this video.